Hello student, today we are going to study elementary transformation in chapter matrices paper 1. First, we can see the elementary transformation. Let us first understand the meaning and application of elementary transformation. The elementary transformation of a matrix are the 3 operations which are due to row transformation and 3 due to column transformation. First, interchanging of any 2 rows or any 2 columns. If we interchange ith row and jth row and it is denoted by Rij, R double implication Rj. If interchanging any 2 columns, it is denoted by CK double implication CI or CKI. For example, matrix A equal to first row elements 1, 0, second row elements -1, 3. Interchange any 2 rows R1, 2. Therefore, the matrix A equivalence to interchanging means first row elements in second place elements in first row elements. That is, first row elements 1, 0 take in second row elements 1, 0 and second row elements -1, 3 write in first row elements -1, 3. We give the operation R1, 2. Second examples taking on column transformation. Matrix A equal to first row elements 5, 4, second row elements 1, 3. Operate interchanging first column and second column. Solution: changing first column and second column, it is denoted by C1, 2 also. C1, 2. First column elements 5, 1 write in second column 5, 1 and second column elements 4, 3 write in first column. This operation is nothing but interchanging first column and second column. Second operation, multiplication of the elements of any rows or columns by a non-zero scalar. If k is a non-zero scalar and the row Ri is to be multiplied by constant k, then we multiply every elements of Ri by the constant k and symbolically it is denoted by Kri. That is, ith row interchanging k into Ri. Or for column transformation, we can say about this is, if k is a non-zero scalar and the column Ci is to be multiplied by the constant k, then we multiply every elements of Ci by the constant k and symbolically it is denoted by k into Ci. That is, Ci column changes to KCI in this type. By taking the examples on this operation, example, B matrix equal to first row elements 1, 0, 2, second row elements 2, 4, 5. Convert this matrix into -3i. That is, operate this operation on B matrix. That is, scalar, non-zero scalar -3 multiply by first row elements. Each first row elements 1, 0, 2. -3 multiply by each element. -3 into 1, -3. 0 into -3 is nothing but 0. 2 into minus 3 is nothing but minus 6. And second row elements same as it is, that is 2, 4, 5. These examples using the row transformation. Second examples, if A equal to matrix, first row elements 1, 2, minus 1, second row element 0, 1, 3, operate the operations 2 into C2, that is non-zero scalar 2 multiplied by column number 2. Column number 2 elements is nothing but 2, 1. First column and third column remain same, only change the column 2. 2 into 2 is nothing but 4. 1 into 2 is nothing but 2. Therefore, A equivalents to matrix, first row elements 1, 4, minus 1, second row element 0, 2, 3. Third, adding the scalar multiples of all the elements of any rows or columns to corresponding elements of any other rows or columns. That is, if k is a non-zero scalar and k is a multiple of the elements of Ri or Ci are to be added to the elements of Rj or Cj, then the transformation is symbolically denoted by Rj interchange to Rj plus k into Ri. For column transformation, notation is denoted by Cj columns interchanges to Cj plus k into Ci. Taking examples on these operations, if A equal to matrix of order 3, first row elements 1, minus 1, 3, second row elements 2, 1, 0, third row elements 9, 9, 3. Operate the operations 3 C3 plus 2 C2. Solution. Third column plus scalar non-zero scalar number 2 multiplied by column number 2. First column and second column remains same. That is, first column elements 1 to 9, right? Same as it is 1 to 9. Second column elements minus 1, 1, 9, right, as same. And third column elements is nothing but 3 plus 2, and corresponding elements of C2 is nothing but minus 1. That is 3 minus 2, value is nothing but minus 1. Second elements, C3 elements is nothing but 0 plus 2 into corresponding elements of 0 is nothing but 1. 2 into 1 is nothing but 2. 2 plus 0 is nothing but 2. Therefore, required number is nothing but 2. Similarly, find the next elements. C3 elements is nothing but 3 plus 2, and corresponding elements of 3 is nothing but 9. 9 into 2 is nothing but 18. 18 plus 3 is nothing but 21. Therefore, our required matrix written as first row elements 1, minus 1, 1, second row elements 2, 1, 2, and third row elements 9, 9, 21. Next, inverse of matrix. Definition. If A is a square matrix of order M, and if there exists another square matrix B of the same order such that AB equal to BA equal to I, where I is an identity matrix of order M, then B is called as the inverse of A, and it is denoted by A raised to minus 1, is called as the A inverse. Using the notation A inverse of B, we get the above equation, as A into A inverse equal to A inverse A equal to I. Hence, using the same definition, we can say that A is also inverse of B. That is, B inverse equal to A. Note that every square matrix A of order m by m has its corresponding determinants. Second, a matrix is said to be invertible if its inverse exists. And third, a square matrix A has inverse if and only if determinant of A not equal to 0. That is, A is non-singular matrix. The inverse of matrix, if it is exists, can be obtained by using two methods. First method is elementary row transformation or elementary column transformation, and second method is nothing but adjoint method. Now study these methods. First, elementary transformation method. First, we can learn about the matrix converted to the identity matrix. For example, convert matrix 1 minus 1 second row elements 2 3 into identity matrix of order 2. Solution. Given matrix A equal to, in general form, it is written as A11, A12, second row elements A21, A22. Convert this matrix into the I2 matrix, that is identity matrix of order 2. And we know that identity matrix of order 2 written as first row elements 1, 0, second row element 0, 1. Therefore, we can use the step as first step, reduce A11 to 1. Second step, reduce A21 to 0. Third step, reduce A22 to 1. Fourth step, reduce A12 to 0. We use these steps serially in this order. We get right given matrix A equal to first row elements 1 minus 1, second row elements 2, 3. First step is nothing but reduce A11 position elements into the 1. These elements already here. Therefore, we go to the second step. Second step is nothing but reduce A21 positions elements 0. Therefore, these two elements changes to 0 using the operation second row elements minus opposite sign of these two is nothing but minus this number with the help of this one, and this one lies in a first row, that is operation written as R2 minus 2 times R1. First row elements return same, that is 1 minus 1. Only changing the second row elements. Operation is nothing but R2 minus 2 times R1. That is taking the A21 position elements is nothing but 2 minus 2, and corresponding elements of 2 is nothing but 1, and simplify this expression, we get value is nothing but 0, and this value is nothing but A21. Similarly, elements in R2 row is nothing but 3 minus 2, and corresponding elements is nothing but minus 1. Minus 2 into minus 1 is nothing but 2. 3 plus 2 is nothing but 5. Therefore, required numbers is nothing but 5. Next step, reduce A2 to 1 positions elements to 0. That is, this 5 convert into the 1. That is, we can divide R2 by 5. the first row remains same. 1 minus 1, 0 divided by 5 is nothing but 0, 5 divided by 5 is nothing but 1. And last step, reduce A1 2 positions elements to 0. And this element is nothing but minus 1. Therefore, we can use the operation R1 plus R2. Therefore, changing first row elements, second row elements at it is R1. First row elements R1 plus corresponding elements 0. 1 plus 0 is nothing but 1. And minus 1 plus 1 is nothing but 0. Therefore, converting matrix written as 1 0 0 1, and which is also denoted by identity matrix and order 2, that is I2. Now take the second example. If A equal to matrix of order 3, that is first row elements 2 1 3, second row elements 1 0 1, third row elements 1 1 1, then convert A matrix into the identity matrix of order 3. Solution. First, how to convert A matrix of order 3 into the I3 matrix? There are 6 steps using the row transformation. First step, reduce A1 1 position elements to 1. Second step, A2 1 positions and reduce A3 1 position elements to 0. Step 3, reduce A2 2 position elements 1. Step 4, reduce A1 2 and A3 2 positions elements to 0. Step 5, reduce A3 3 1 position elements to 1. And last step, reduce A1 3 and A2 3 positions elements to 0 using the row transformation. If we can use the column transformation, therefore apply the following step. Step 1, reduce A1 1 position elements into the 1. Second step, reduce A1 2 and A1 3 positions elements 0 to 0. Step 3, reduce A2 2 position elements to 1. Step 4, reduce A2 1 and A2 3 to 0. Step 5, reduce A3 3 position elements to 1. And step 6, reduce A3 1 and A3 2 elements to 0. With the help of this row transformation step, we can convert the given matrix into the I3 matrix. Therefore, first step is nothing but reduce A1 1 position element to 1. Therefore, we can interchange R3 and R1. It is written as R31. Therefore, A equivalence to interchanges the second row elements at it is, that is 2 1 3 go to the third row elements and 1 1 1 these elements write in first row elements. Second row elements remain same 1 0 1. Second step, A3 1 positions element, reduce A3 1 positions elements to 0. Therefore, it is written as A3 minus 2 times R1. That is, first row elements and second row elements remain same 1 1 0 1 0 1. And third row elements written as third row elements. First row elements is nothing but 2 minus 2 and corresponding element is nothing but 1. Simplify this, we get 0. Second elements is nothing but 1 minus corresponding elements is nothing but 1. and 1 minus 2 simplify, get minus 1. And third, elements 3 minus 2, corresponding elements 1. 3 minus 2 is nothing but 1. Therefore, matrix convert into the matrix 1 1 1 1 0 1 0 minus 1 1. Next step, convert, reduce A21 positions element to 0. A21 position elements is nothing but 1. Therefore, we can operate operations R2 minus R1. Therefore, 1 elements become 0. First row element and third row elements remain same, that is 1 1 1 0 minus 1 1. Only changing second row elements. Second row elements is nothing but 1 minus 1 is nothing but 0. 0 minus 1 is nothing but minus 1. 1 minus 1 is nothing but 0. Next step, reduce A22 positions elements to 1. That is, this minus 1 convert into the plus 1 using the operations R minus 1 R2. Minus 1 multiplied by R2 rows. That is, matrix convert into the matrix 1 1 1, first row elements, third row element 0 minus 1 1, and we multiply minus 1 into the R2 row. Minus 1 into 0 0, minus 1 into minus 1 is nothing but 1, 0 into minus 1 is nothing but 0. Next step, reduce A32 position elements to 0 using the operation R3 plus R2. That is, first row elements 1 1 1, second row elements 0 1 0 remain same, only changing the third row elements using the operation R3 plus R2. R3 elements is nothing but 0 0 and its corresponding elements is nothing but 0. 0 plus 0 is nothing but 0. Second, R3 elements is nothing but minus 1 plus R2 elements is 1. Minus 1 plus 1 is nothing but 0. And third, R3 elements 1 and corresponding element 0. 1 plus 0 is nothing but 1. Next operation, reduce A12 position elements to 0 using the operation R1 minus R2. Changing first row element R1 minus R2. 1 minus 0 1. 1 minus 1 is nothing but 0. 1 minus 0 is nothing but 1. Second row elements and third row elements remain same. And last, A33 positions, reduce A33 position element into the 1. This step already here. Next step, A23 positions elements to 0. Convert this element. This step also here. And last step, reduce A13 positions elements into the 0 using the operation R1 minus R3. First row only changes, R2 and R3 remains same. 1 minus 0 is nothing but 1. 0 minus 0 is nothing but 0. 1 minus 1 is nothing but 0. Therefore, first row elements is nothing but 1 0 0. Second row element 0 1 0. Third row element 0 0 1, which is nothing but identity matrix, and order is 3. Therefore, it is written as I3 matrix.